So next up here, I think we're going to go ahead and wind the transformers. I decided to just go ahead and get that part out of the way. And the way they sell these toroids is there's a T designation, which means toroid, and then you've got a number, the number after that, which in this case we're doing a T50. The 50 would correspond to the inside diameter, so that it's in inches, so it's 0.50 inches on the inside diameter of the circle, and then the number on the end, in this case 43, is as I understand it, it has to do with the substance of the toroid, how much iron it has in it, or whatever other metals they put in there. So it basically just changes the electrical properties of the toroid. So when you buy these, they can be kind of a pain, or I've found there can be a little bit of a pain to search for on different places like Jameco and LCSC, but I think I got these from exactly what the bill of materials listed for in the well, it says Mouser, so that's T5043. And if you go to toroids.info, they have a lot of good information on this, and it even tells you that a T5043 should be black. I think it actually says shiny black is the description. So I believe that this is what I think it is. So we need that, and the next thing we need is some enameled wire, or what they often refer to, I've heard it called magnet wire. This wire has a coating on it so that there's no electrical connection when it touches itself or another wire. So when you wind a transformer, there's an electromagnetic connection to the wires, but there's no electrical connection. So if you wind up a transformer with this, let's just say it was 2 wires, so you would have at the end of the day, you would have 2 on each side. You shouldn't get any continuity from between the primary and secondary windings. And that's because even though the wires are touching each other, because of that coating on here that will allow the electromagnetic energy to go through the transformer, but not electrical, a DC current. So to help explain this a little bit better, that's good coffee. So what I have, I printed out part of my schematic, and you can go look at their schematic and see mine's drawn slightly different because this came from Easy EDA where I laid my board out, but the idea is basically the same, and it looks very similar. So here, this side here, we have the mixer, the double balance diode ring mixer, and then this side here we have the 40-meter bandpass filter, and in between we've got this transformer that we need to help match the impedance. At least that's my understanding, and I'm not sure how it changes. I'm sure it changes the voltage some too, but this is going to look a little bit different if you're doing it on a proto board or Manhattan style. I'll try to explain kind of both things that are going on here to make it easier to understand. But in my layout, this is pin 1, 2, 3, 4, 5, and 6. So there's 2 pins here, right? Because this is a wire, this is a wire, and this is a wire. So that makes up the 3 wires that we're going to wind this toroid with. And if you look at the footprint on my board, it may be kind of hard to see, but this is T1 here. And so you can see there's 6 holes. And I thought I was making it a little easier by doing it this way. Maybe it is, but here is what the footprint looks like. Here I printed out so you could see it kind of better. So I put there's a 3 here. That square denotes pin 1, so that way I would kind of know which direction. So 1, 2, 3, 4, 5, and 6. And again, looking at the board, you see that 3 on the silk screen there. So you got pins 1, 2, 3, 4, 5, and 6. So in order to make this a little bit more interesting, the way I think we're going to call this, I'll write the pin numbers here. 2, and we got 3, 4, 5, and 6. I'm going to call this one Rachel, and then we're going to call these 2, we don't really care which one's which. I'm going to call these Monica and Phoebe. Make this easier to understand. So the next part is I need to cut 3 pieces of wire off of this. This is 26 gauge, by the way. If you use a different gauge, you're going to get slightly different inductance. So I tried to stick with what they used, which was 26, even though I already had some bigger stuff laying around. And there's ways to recalculate this stuff. I don't feel comfortable enough doing that, or I would have, instead of buying a different size enameled wire than I already had. But I'm sure I'll feel bolder next time I build one of these with experimenting. But I'm going to cut 3 lengths of wire, and then I'm going to twist those 3 lengths of wire together, and then I'm going to wrap 10 turns around this, and then I'll get back and we'll go from there. Okay, I got the 3 wires twisted together. Hopefully this is long enough, but you can see just got 3 wires, and I just twisted them together. I didn't go super tight because I feel like that would have kind of affect the length of it. That's the actual wire that's going to go around the transformer. Or the toroid. So I'll get this wound up. So here it is in all of its glory. I cut the excess wire off. There wasn't too much excess wire. That's all there really was. So, the other side just had a little bit of excess. So yeah, I didn't waste too much wire. But this, we need to figure out which one of these wires on one side is actually the wire on the other side. We can do that with a continuity check, but there's enamel on these wires, so as I said before, which prevents an electrical connection. So we got to defeat that somehow. There's other ways to do this. Yeah, I'm just gonna burn that stuff off. Ow. You can see hopefully you can see they're kind of the difference. Some of that's not burned off all the way there. Okay. Yeah, and you can kind of see like there's a kind of a gold tinge to the ends of it now, where that enamel stuff has been burnt off of it. So what I'll do now is I'll connect an alligator. I'm gonna blow my candle out. I'll connect an alligator clip here and get my voltmeter. And we're gonna put him on continuity. And then connect this side to that lead. That way I don't have to hold all that stuff with my hand. So again, we're just trying to figure out which one of these wires is which. Not that one. Not a good sign, is it? I guess all the enamel's not gone off that. Yeah, so it's that one. So you may not be able to see this too well, but I know so these two are a pair, right? So what I'm going to do is unwrap some more of that one. Or hold on. So I didn't want to make you have to watch me unwrap all that. So these two are a pair. And it doesn't matter which pair is which since they're all the same length. So in order to keep this straight, what I'm going to do is just take a piece of heat shrink and I'm just gonna mark these with some electrical tape, wrap some heat shrink around it so I don't get them mixed up right now. So those two that are there, I know, oh, those are my primary. So those two are, it's really just one wire, but there's two ends, right? That's pins 1 and 2, and that's this wire here, which we're calling Rachel. That's our primary winding. So now we need to find the next two pair. So we'll just do the same thing again. So it's this one. And that one there. Let me unwind him to make this a little bit easier on myself. Gosh, I almost want to check it again. There we go. So these two, right, the ones I have right beside each other, that's a pair. Okay. So I'm going to set that there for a second. Give me another piece of tape. that's just temporary. So now these two, they should definitely have continuity to each other because they're the only two left. I don't think I got all that. Yeah. So they do. So I think we did everything right. So what we need to do now is we've got to connect. Remember, this is a wire and this is a wire. So one side of it, that wire goes to the circuit, one side goes to the circuit, and then one side of each one of those goes to the ground. So what we've got to do is basically, it doesn't really matter which set, but two of those, we need to take one from here and one from here and twist them together, and then those two can go to ground, and then the other two will go here and here. But again, it doesn't really matter which way we do it. It doesn't make any difference. So yeah, we need one wire from here. So I've got to I'll just untwist one of these. This one I'm holding here, this is my target, and then one of these two here randomly. So those two right there, and they'll get twisted together, or connected together, I should say. So again, it doesn't really matter which one of these sets is which here, but we've got our primary marked, and it's just this again. This is just one wire. It's just from one side of the winding to the other, and then these other two wires, instead of having the two ends and then the two ends, what we've got is one wire and another wire. So in other words, these two don't have continuity. These two don't have continuity. But one of these would have continuity from here, and one would have continuity from the other, whichever way, either from a kind of an X pattern or a cross, or just across from each other. We don't know, and we don't care. And for me, I have to worry about how to hook this up to the actual pads here. And 1 and 2, again, that's this primary. 1 and 2 is going to be these two wires right here that are wrapped inside that heat shrink and electrical tape. And then 3 and 4, and this is a little bit confusing because this is 3, 4, 5, and 6. So I need basically one of these, doesn't matter which one goes to 3. One of these doesn't matter which one goes to 4. One goes to 5, and then another goes to 6. So hopefully that makes sense. And again, I don't have to connect these. If you're doing this Manhattan style or on a proto board or something, you need to connect these two wires. Two of these, you need to connect one of these pairs here together, and you need to solder them together or solder them together on the actual circuit board somehow. But I don't have to do that because they're already connected to each other through the traces on the board. So I don't have to worry about that. I just stick the wires through there and solder them. So I'll solder everything up, and then we'll put our leads across it and just kind of double check everything. Okay, I had kind of a rough go with this. So the last one, this is the second one. The first one, I installed it onto the board, and I thought that I had it wrong because I was kind of looking at where I was getting continuity on these pins, and it sort of dawned on me after I pulled the transformer back out that the ones that are connected to ground, I mean, everything there is just going to always have continuity to each other because of the ground. And so the whole secondary winding, pretty much everything, is going to all have continuity between itself. And I was in my mind, I just didn't have um, my mind right, because out of the circuit, I mean, that's different, but in circuit, yeah, all those pins on the secondary winding, they would all have continuity because they all go to ground. And matter of fact, it has continuity to one of the pins on the second primary winding because it goes to ground. So it's kind of hard to check yourself after you install the transformers. I think you'd be better off to go back through this after you've wound it. I did discover one trick along the way, and that is to use some Kapton tape. You can see I've got him wrapped up in a couple layers of Kapton tape. I found my primary, and then I wrapped some tape and kind of put him, what is that, 90 degrees over here on this side. And then I found the next two that had continuity, which is going to be pins 3 and 4, and put another piece of Kapton tape, and then that only left these two by process of elimination. So again, I kind of wrapped another little piece of Kapton and put those 90 degrees off, and then I flagged the primary with some tape, and then I left this alligator clip on the middle too for now. But the Kapton tape really helps. It really helps keep you from mixing up all the wires a little bit, and it just kind of makes it look a little bit cleaner and nicer. I think using a different colored wire, you could use an insulated wire for one of the three wires, and that would probably help out a lot too. I think it would be kind of hard to find insulated wire this small, but you certainly could. It's, again, I think this is 28 gauge if I remember right, so it's pretty darn small. But I had a problem when I unsoldered this for the first time, or the only time, I guess, in order to rewind it and put it back in, because I thought I'd gotten a short and messed something up. One of the pads I lifted. So luckily it was this pad, so I just bridged it with a piece of the wire itself, or maybe it was the one. Yeah, I don't remember. Maybe it was this one that needed to go back to ground. I bridged. I don't remember. But anyway, I fixed it. Luckily, it wasn't a big deal. I didn't have to redo the whole board because I don't have any stuff to repair pads or traces. I need to kind of learn how to do that too. But one of the pads, I lifted a corner, but not the whole thing. So that's, usually I'm pretty good about desoldering, but I think part of the problem was I had turned my heat up on my iron to kind of remove some of this coating, and I'd forgot to turn it back down whenever I went to use my solder wick here, and it just kind of got to be a mess. But this coating on this particular brand, this stuff is really hard to get off. I mean, even running it over a candle, it doesn't come off very well at all. You got to get the wire pretty darn hot. I even used a plasma lighter thing, and it doesn't hardly get it off either. So one of the problems is, because you've got 6 wires here, and I'm putting it through a circuit board, it would be really hard to cut these to the appropriate length and then get the wire off, because you'd end up getting a short if you weren't careful. So it's almost better just to put this into the board and then just use your iron to kind of scrape some of that stuff off, and you end up getting some gunk on the board that you have to clean off, but that's not the end of the world. So I think I'm just going to kind of accept that with these tri-fillers as kind of being the way to do it until I find a better way. But let's now I think we'll wind up the other 2 transformers. I think they just have 2 windings, so hopefully it should be a little easier. All right, I've got a little bit of solder on the end of my tip here, so I've got it tinned pretty well, and I'm gonna attempt to kind of just get some of that stuff off, that coating. This is definitely not fun. It's trying to solder itself actually when I don't really want it to. Yeah, a lot of that. Clean my tip a little bit. I'm just going to put some heat on it. That may have got enough of that coating off to be okay. I was just kind of trying to show y'all what the process looks like trying to scrape that stuff off. It does not want to come off. I think I'm going to turn my iron up. It's on 350. I'm going to go to 400 and re-tin my tip. Maybe this will help because it seems like the solder's not really sticking to the wire, so that kind of makes me think the coating's still on there. Yeah, I think it's burning off now. I can smell it. Okay. Yeah, you can see the solder sticking to the wire, so I think that's a good sign. Yeah, this is kind of gross, but I mean, honestly, I think, yeah, that is such a cold looking joint. I think this is kind of the better way, or at least until I find something else. Yeah, that still looks bad. Yeah, a lot of that flux and black looking stuff, I mean, that's all going to clean up, but well, anyway, there you can kind of see what it looks like. It's not pretty doing it this way. You could try to take a box cutter and scrape that stuff off. I've done that before, but again, this particular brand, it is very stubborn. So I'm going to do these other ones and we'll see what it looks like. We thought of a trick. I don't know if it's a trick or not, but I don't think I don't have a lot of great ideas, but this is Cat 5e cable, just cheap Ethernet cable. I've had this for years and years. I think this is 26 gauge. Could be 24. I don't know if they make this stuff in 28, but so the wire is a little bit bigger, but I think it would still work for a toroid like this. I'm not positive about that. This is one of these cheap networking tools. It's for cutting the outer sheath on these, and then it doubles as a punch down tool. So you don't obviously have to have one of these. But I'm going to pull that apart. And if you look, so now we've got 4 twisted pairs. So if you wanted to, let's see, is there a cutter on this? No. But if you wanted to, you could take one of these twisted pairs and then take one wire from another one of these and twist it around the other set. And I think you know where I'm going with this. So in other words, you'd kind of do like this, right? And then if you wrap that around the toroid, what you're going to get, if you went ahead and wrapped, your full 10 turns, which I'm not going to do because I didn't cut this. But at the end of the day, you would have three different colored wires, so you would know on each side which wire's which without using your your meter or anything. And I would think pretty much everybody's got some old Ethernet cable. I mean, you can buy this stuff super cheap, or just cannibalize one that you got laying around, like a 3-footer or something. I don't know that this would work always on all toroids, because obviously with insulation on here, it's going to take up a lot more space. But I mean, just looking, I would think you could get 10 turns of that on there. And then you don't have to worry about using your meter to check to see which wires which, or getting them mixed up. And 2 of the wires are already twisted for you. So I just thought I would show that little tip, because I think that if I could go back in time, I might have done it that way. But again, I'm not 100% sure what changing the wire size does. I don't think the insulation here affects it too much, but I think going to a larger wire size, maybe it might change it some. I mean, I doubt it would affect it a lot in this case, but anyway, just thought I would share that. Okay, so, well, 2 things. I've got the other transformers wound, the ones that couple. They're for the input and output of the of the 40 meter bandpass filter. So I don't have all that circuit on here, but there's one here to adjust the output impedance to 50 ohms, and then there's one on the other side for the antenna that adjusts the impedance. It allows you to have the 50 ohm impedance of the antenna, and then I don't know what the impedance of this circuit is. I'm thinking, well, it's probably over 1,000, I guess. I don't honestly know, but so I wound one of those. Their instructions are to use 26 gauge wire, 26 turns, and then it said 5 turns of hookup wire. I actually used that Ethernet wire that I was talking about, since I'd already cut it. And I got to thinking, this is actually, even for this transformer, these tri-fillers that I've already wound, and you can see are wrapped and capped on tape, that is 26 gauge. I was thinking it was 28, and this Ethernet wire, I believe, is 26. The solid copper, they've got some thicker stuff that's for more intensive PoE applications, and I believe it is 24, but I think most of this Ethernet wire is going to be 26. There's some like copper clad aluminum stuff. It's kind of a pain to work with from when you're making cables, but I don't know that it would make a lot of difference either for these transformers. So I definitely think that the Ethernet cable is worth a try. In this case, it probably wouldn't work too good for the whole thing, because trying to get 26 turns, that might be a little bit too thick. But that's what it looks like. It's not super pretty, but I think it'll do the job. I tried to check the inductance with my little Finercy component tester, and I guess it's just not sensitive enough to check 3 microhenries, because it's just registering as 0.3 ohms of resistance. So I tried several times. So I don't have a proper LCR meter, but hopefully the inductance is okay. It's pretty close. I followed the instructions. I imagine it's pretty close. I think it's the turns ratio that probably matters more here. I think the inductance that you get is kind of more of just a symptom that you've used the correct number of turns, would be my guess. But I'm going to get this guy soldered in, and then I wind another one just like it, and they go on my board. They go here and here. But again, they're both part of the 40 meter bandpass filter. So if you're doing this like Manhattan style or on a proto board, these are going to go in the same general area. And I did use a candle to burn the ends of these wires off. Again, man, you just got to leave it in there for like at least 5 seconds or more. That stuff just won't burn off. So anyway, all right, well, I think we'll stop this one here. And then in the next part, I got the I got these variable capacitors soldered in, and then there's a Zener diode. I soldered that in because there's a handful of through hole. I've got to get the audio transformer soldered in, and the BNC connector, and then I've got a voltage regulator, which if you're following Solder Smoke's exact instructions, you won't have that, because again, I put a voltage regulator because I'm going to feed this thing 14 volts, and this circuit up here is going to knock that back to 9.5 volts. So it's going to simulate running on a 9-volt battery. So that gave me a couple extra components. I think I mentioned that before. And then I've got some test ports. So you see there's and then I've got a place to connect power and speaker. Yeah, that one's the speaker. This is where the 3D printed inductor connection is going to go. So I basically just got a little bit more soldering to go, and then hopefully can power it up and test it. So we'll show you what that looks like. Hopefully in the next video we'll have some fun. We'll actually see, we'll actually harm some electrons and see, maybe check some voltages and put it on the oscilloscope if everything goes well. So we'll hopefully you'll tune in for the next installment. Same bat time, same bat channel, back with the Code Slinger.